Hi everyone, welcome back. We are going to start our new unit right in the middle of one at 11:05, and we're going to talk today about the distance formula. And when we're talking about the distance formula, what we're asking is what is the distance between two specific points. So here, I want to know the distance between 1, 2 and 5, 5. Well, I know I could just measure this, but the problem is I don't really have any units, and also measurements can be a little bit inexact. I might end up between 2 points, it might be a little bit of an estimate, and I'd really like to know for sure using only the numbers it gives me. So what I can consider here is what shapes could I form around this object, or how did I get this line? And when I look at this, I notice that while I could say I went from here to here, I could also say that I moved 4 over, and then I went 3 up. And notice that gets me to the exact same place. And what I have done is I've formed a very specific shape, a sort of shape that we have done a ton with and will continue to do more with, a right triangle. And as soon as you see a right triangle, there should be like these little bells going off in your head, because there's a certain formula that we almost always use with the right triangle, where we say a squared plus b squared equals c squared. That's right, the Pythagorean theorem. So this formula might just help us out. Well, let's see why. I know that in order to get from 1, 2 to 5, 5, I moved over 4. So this right here is a distance of 4. And I know that I moved up a distance of 3. And notice it doesn't matter positive or negative, distance is always going to be considered positive. So when I'm looking at my Pythagorean theorem, and I know I want to figure out what this distance is, which I'm just going to relabel as a d instead of c. I'm talking about the hypotenuse, so this is going to be the c squared or d squared. And when I'm looking at my a value, I'm talking about one of the legs, so I'm just going to call that the 4 squared. And my b value would be the other leg, or 3 squared. So I can find out what my distance is, that hypotenuse, by just taking the square root of both sides. And if you solve this, you'll find that d is equal to 5. So I can find my distance using the Pythagorean theorem, which is pretty great. But there are ways to do this without needing a graph, because do you really want to graph this whole thing every time? Probably not. So let's find ourselves a distance formula using only what we know about the Pythagorean theorem and a little bit of common sense. So let's set 2 random points on a graph and say I want to know what is the distance between these 2 random points. Now this time I'm not going to be able to count the distance between them because I've just dropped these points on here. I don't actually know that I've dropped 4 or 5 boxes down. I don't know that I've gone 4 or 5 boxes over. I just guessed, so I'd have a picture to work with. But I'm going to do what I did last time, and I'm going to look at how I moved over and up, because I know that that way I can have a right triangle. So I know that I moved over a certain distance, and I moved up or down a certain distance. Again, up and down don't matter because we're talking about distances. Positive and negative don't matter with distances. So I have my right triangle here. Now this time, instead of lengths though, all I know is that this is however long it took me to go from here to here. And since we're talking about x here, I'm saying what is the difference between x2 and x1? And I can find that difference by just going down here and just saying, well, what is x2 minus x1? And so I'm going to mark that distance in as that equation or expression, x2 minus x1. And you could see in our previous problem, that would work, our x2 minus x1. So when we're looking up here, my x2 would be 5, my x1 is 1, and 5 minus 1 is the distance I've gone over, 4. Let's do the same thing with y. When I look at my y, I'm talking about how far did I go up. Well, you can see that the distance here is between this y1 and this y2. And what I'm going to do is I'm going to take y2 minus y1 to find what that overall distance is. So this length here is y2 minus y1. Well, that means that when I start to fill in my formula, because hey, I would still like to be able to know what this distance is, what I'm going to end up with is d squared is equal to the two legs of my triangles added together and squared as well. So I have my a squared, or x2 minus x1 squared, plus my b squared, or my y2 minus y1 squared. And by the way, it turns out it doesn't really matter which way you go. One of these is going to, like if I did y1 minus y2 versus y2 minus y1, one will give you a negative answer and one will give you a positive answer. And either way, when we square them, they're both going to give us the same. So like if I had said this is 5 and this is 2, I would have gotten 5 minus 2 is 3, or 2 minus 5 is negative 3. 3 squared is 9, negative 3 squared is also 9, so I'd still get a 9 when I dropped it into my formula. That's why it doesn't really matter which order you do these in. But we have found our formula. Let's just make it so that d is all the way by itself, because we don't want to find the distance squared. We want to find just the distance. So that right there is your distance formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's do a little bit of practice. So what is the distance between negative 26.7 and 28.25? Well, as you guys can see, I've already written out the distance formula. That's kind of a given since, hey, we just learned how to do it. We're going to do an example problem. But you should be able to see distance as a trigger that you might need this formula. So as soon as you see the word distance, at least have this formula pop up in the back of your mind. You might want to use it. At the very least, it won't hurt to look to see if you have enough information for it. And remember, all it takes to fill in a distance formula is either a distance or 2 points. So that means since I've been given 2 points, it makes sense to use this formula. Now what I need is I need to find my x's and my y's. And in any given coordinate, you always have your x followed by your y, just like alphabetical order, right? So here I could call this my first point with x1, y1, and this one my second point with x2, y2. And that means that I just need to copy down and fill in my formula. Remember, your formula is the guideline to any problem. So here I'm going to do x2, which is 28, minus x1. Oh, watch this. There is a negative here, so that means I'm going to get a negative 26 placed inside of there, okay? So don't lose that negative. In fact, if you have a negative, you might want to circle it or highlight it, and when you put it into an equation, use parentheses around it so you don't accidentally lose it. In our second part, we have y2, which I'm just going to fill in with 25, and y1, which is 7. And I can actually go through and I could just type this directly into my calculator. I am going to simplify it a little bit. First off, I know that minus a negative number is the same as addition, so what I'm really saying here is 28 plus 26, and that gives me an answer of 54. So I'm saying that this value inside the parentheses is 54. And 25 minus 7, well, that's going to give us 18. So I end up with an 18 over here. And when you're doing this sort of simplification, make sure that you keep in the back of your mind the things that you haven't changed. So for instance, I have not taken the square root. I have not added things. And I definitely haven't taken these squares either. So all of this stuff still needs to be done. And at this point, if you wanted to just type this into your calculator, there's nothing wrong with that. Your calculator will actually tell you the answer, and it will do it correctly when you type it in, so that if I were to type in this, all underneath the square root sign, I added some parentheses here, even though it's not really needed, as you can see, because I didn't even put them around this one, I'd end up with an answer 56.921, about 56.921. And notice I did take the square root in that, so everything at this point is done. and I would be finished with my problem.